Hello and welcome to Marriott MBA Today. I'm your host, John Holbrook. Today we're doing a story about an invention made by a BYU professor that can virtually eliminate pollution from coal power plants. MBA Today reporter John Hansen shows us how this device not only improves the environment, but also unlocks the cheapest and most abundant source of energy in the world.
As more and more regulations are placed on emissions within the United States, the ones who really feel the pressure aren't those driving on the freeway, but those who produce the power to light your home.
Crews cut mounds of coal from deep inside this mountain in central Utah. Companies like Utah Power and Light burn this coal to generate the electricity used to power homes in Utah and throughout the western United States. Until a few years ago, more than 50% of the electricity generated in the U.S. came from coal. But CO2 and other pollutants emitted by the plants threaten the environment and brought strict government regulations that now threaten the coal industry.
So much of our energy comes from fossil fuels that it'd just be a huge undertaking to try to completely just start from scratch with a new power supply.
Many coal plants like this one in Delta are being converted to natural gas at a cost of nearly $2 billion. But BYU Professor Larry Baxter says he has a better idea.
This is a process that's designed to capture carbon dioxide and mitigate climate change.
Baxter calls it the carbon capturer. Crews bolt it onto the side of a fossil fuel burning power plant where it scrubs the emissions before they come out of the stacks, removing almost all of the carbon dioxide pollutants that damage the environment.
CO2 is the single most significant contributor to climate change, global climate change. So this is a technology that will take the exhaust from any of those processes basically and separate the CO2 out so that we can store it somewhere where it doesn't contribute to climate change.
The carbon capturer cools the emissions from the plant so that the carbon separates and falls out. The clean air then exits the plant and the dangerous pollutants get stored in containers and get disposed of in a way that won't damage the environment.
The process itself is pretty simple. It's basically a giant refrigeration system of sorts, except that unlike a normal refrigeration system, the things we produce are at the same temperature at the end of the process as they started at the beginning of the process. And that's part of what makes it so efficient.
Baxter's research says that the process can reduce carbon emissions from fossil fuel powered plants by up to 99%, and it does it at half the cost of other systems. If you could see inside the carbon capturer, Baxter says you would see a winter wonderland.
We form what does look like the worst blizzard you've ever seen in this flute in these chambers, and those solid particles then accumulate as solids. The gases are still light gases, and so they're relatively easy to separate. We separate the solids from the gases, and then we pressurize the solids and warm them back up again, warm the gases and the solids back up again. And we use those to do most of the cooling for the gas that's coming in.
Baxter says his invention would prevent coal power plants around the world from closing down or preventing operators from spending billions of dollars to switch over to natural gas to produce electricity.
So you can take an existing coal plant, which has a huge carbon footprint, and now make that a carbon negative footprint by co-firing with biomass.
A few years ago, Professor Baxter started a company called Sustainable Energy Solutions to commercialize his invention. Chris Bentz is the project manager where they currently make the carbon capturer. He says the technology can clean up the exhaust from any fossil-burning plant, like this gas refinery in Salt Lake City.
Economically, I think it makes the most sense to start on the coal plants. There's quite a few in the States, a few more in China, and throughout Europe and the rest of the world.
BYU biology professor Rick Gill says that the world community must find a way to reduce the levels of carbon dioxide pollution in the environment or risk what he calls catastrophic impacts.
What they're forecasting for the desert Southwest is that if we continue on a business as usual, that we'll end up with 30% less water in the desert Southwest at a time when population will double or triple, right? So already this year we see what happens if you have a single winter without rain in California, right? That there's panic that they don't know what the farmers are going to be able to do. Well, what happens if that becomes decadal?
So far, sustainable energy solutions have only demonstrated the carbon capture and are still in the prototype phase of development. But the coal industry is interested in finding a low-cost solution. In an email sent to us for this story, Dean Wood, the engineering supervisor of the Intermountain Power Service Corp in Delta, Utah, said that if an economical means of capturing CO and CO2 could be developed, coal-fired plants may yet have a place in the national power generation portfolio. Professor Baxter believes that renewable energy will likely bring the solution for future generations, but he thinks his invention will prevent damage to the environment and allow the continued use of low-cost and highly efficient fossil fuels.
Well, you need alternatives. You need to be able to use lots of different alternatives, and this technology enables the large fraction of the 85% of the energy that we produce right now from combustion processes to continue to be a useful, affordable, economic, and stable source of energy while we develop alternatives and do other kinds of things.
Baxter says they have already completed and demonstrated several prototypes of the carbon capture. He says the next one will be completed in the next month and will produce about a ton of CO2 per day. Baxter says that they plan to have the first commercial system up and running by 2017.
John, thanks for that report. It'll be interesting to watch the progress of Dr. Baxter's technology in the coming years. I'm John Holbrook, and thanks for watching Marriott MBA Today.